So we've gone to all the effort to work out these two formulas for tangential acceleration and normal acceleration. So let's just work through an example to see how they work out. Remember, the reason that we did this is because to calculate these two things directly, you'd have to calculate tangential and normal acceleration directly. You'd have to explicitly calculate t, which is okay. We're going to have to compute all of these pieces anyway. T is r prime over length of r prime. But then you'd also have to explicitly calculate n, which is t prime over the magnitude of t prime. And t prime, like to differentiate t, you'd have to differentiate this magnitude in the denominator, and that frequently makes a giant mess, right? Because this magnitude is really the square root of a bunch of stuff. And differentiating that, I mean, it's always possible, but it's also frequently very annoying. So it's nice to have these formulas so that we don't need to explicitly calculate t and n. All right, so let's see what we get for tangential and normal acceleration for this curve. So let's calculate. R prime is taking a derivative. We get 1 comma 2e to the t comma, let's see, the chain rule spits out a 2 here, so 2e to the 2t. All right, and then magnitude of r prime. Right, we're going to need the magnitude of r prime to use these formulas, so let's calculate this now. Magnitude of r prime is the square root of 1 squared plus 2e to the t squared, so that's 4e to the t squared, that's e to the 2t, plus 2e to the 2t squared, so that's 4 times e to the 2t squared, that's e to the 4t, right? Yeah. Right? Yeah. Like this. Okay. Note that this, of course, this doesn't always happen, but this is set up so that this is actually a perfect square. This is 1 plus 2e to the 2t squared. So this is 1 plus 2e to the 2t. Okay. But you'll see that as we do the rest of the calculation, nowhere in computing these two formulas, nowhere do we ever differentiate the magnitude of r prime. So even if this nice simplifying didn't happen, the square root wouldn't be causing us a bunch of trouble because we're never differentiating a magnitude. Okay, so now that we have r prime, the magnitude of r prime, let's calculate r double prime. So that's going to be 0, 2e to the t, and then the chain rule is going to spit out another factor of 2, so 4e to the 2t. Okay, and the reason we calculated r double prime is so that we could dot it with r prime and cross it with r prime. So r prime dot r double prime. I don't remember which order I put this dot product in, but when we figured out the formula, but remember, it doesn't matter because it's a dot product. So r prime dot r double prime, so I'm dotting r prime up here with r double prime down there, so 1 times 0 is 0, plus 2e to the t times 2e to the t, that's 4e to the 2t, plus, and then 2e to the 2t times 4e to the 2t is 2 times 2 is 4, and then e to the 2t times e to the 2t is e to the 4t. Okay, so there's r prime dot r double prime. It's 4 times e to the, actually, I should factor out everything I can. So this is 4e to the 2t times 1 plus 2e to the 2t. I think that's right. That looks good. So there's r prime dot r double prime. I'm also going to need r prime cross r double prime. And also for this one, I don't remember which way we had this cross product, but remember, we're going to take the magnitude of this. And so for the magnitude, it doesn't matter which order it's in. So let's do this cross product, and I'm using my little crossing trick for the cross product of vectors. So I'm doing this cross first. So that's going to be 2e to the t times 4e to the 2t. So that's 8e to the 3t minus And then the other leg of this cross is 2 times 2 is 4 e to the 3t. Okay, that's going to simplify nicely. And then the wide cross like this, I get 0 for the first product minus, and then on the second product I get 4e to the 2t. And then finally this, the narrow cross here, so it's 2e to the t, 2e to the, sorry, 2e to the t minus, and then the other product is 0. Okay, so this is, looks like 4e to the 3t, comma, minus 4e to the 2t, comma, 2e to the t. Okay, we're going to take the magnitude of this. To calculate magnitudes, it's nice to have common multiples factored out, so let's factor out a 2e to the t. So this leaves us with 2e to the 2t minus 2e to the t and 1. Okay, now we need the magnitude of the cross product, so magnitude of r prime cross r double prime. That this scalar in front, we can move it outside the magnitude by taking its absolute value, but 2e to the t is already positive, so 2e to the t, and then times the magnitude of everything that's left. 2e, sorry, I need to square this, so I'm computing magnitude, so square this. 4e to the 4t plus 4e to the 2t plus 1. Okay. And notice that this little miracle of the perfect square has happened again. So the stuff inside the square root is 2e to the 2t plus 1 squared. And so this whole mess is 2e to the t times 2e to the 2t plus 1. Oh, I didn't write a plus 1 right here. Okay, now finally we can compute the tangential component of acceleration. It's r prime dot r double prime over magnitude of r prime, and r prime dot r double prime was up here. So this whole thing, actually notice that these two are actually almost the same. The dot product is twice the magnitude of the cross product. So this was 4 times, sorry, I'm going to have to scroll back and forth. 4 times 1 plus 2e to the 2t, and then divided by the magnitude of the dot product, which is up here somewhere. What was the magnitude of the dot product? Right here. 1 plus 2e to the 2t. Oh, look. Nice. This cancels and we get 4. Okay, and then the normal component of acceleration, so that's magnitude of r prime cross r double prime over magnitude of r prime is 2e to the t times 2e to the 2t plus 1 over magnitude of r prime was 2e to the 2t plus 1. And so this cancels that, and we get 2e to the t. And I think back here I dropped something, didn't I? Did I drop an e to the t? I did, an e to the 2t, yeah. So I dropped an e to the 2t right here. So this should have an e to the 2t. And but this one is e to the t. Yes. Okay, there we go. So we got our tangential acceleration, our normal acceleration. I'm not saying that it isn't a longish calculation. It is, but at least we didn't have to differentiate any magnitudes. That's the whole point of these two formulas.